Why do all the stars and planets move so gracefully through space? It's all thanks to something called Kawecki's bubble. According to Kawecki, it's this incredible bubble that sets the universe in motion. Imagine the universe as a gigantic cosmic dance floor. Without this bubble, the stars and planets would be standing still. No groovy moves at all. So, how does it work? Kawecki's bubble exerts an energy content that translates to a whopping 450,000 miles per second squared. That's like having a sports car that can accelerate to 450,000 miles per second in an instant. This energy gives the universe its push velocity, driving everything forward. Now picture all the galaxies as dancers on this cosmic floor. The bubble's powerful push force keeps them gliding smoothly, stabilizing them at a uniform rate of 43 miles per second. This keeps our universe's momentum steady and balanced. In simpler terms, Kawecki's bubble is the ultimate cosmic engine. It ensures that the universe doesn't just sit around doing nothing, but instead keeps expanding and moving with grace and precision. So the next time you gaze up at the night sky, remember it's Kawecki's bubble that's making the universe groove. Thanks for watching. Don't forget to like, subscribe, and keep exploring the cosmos with us. Imagine looking up at the night sky, dotted with countless stars. Each one of those tiny points of light represents a distant sun, many of which have their own planets orbiting them. The vastness of the night sky is a window into the enormity of the universe. Now imagine yourself shrinking down to an incredibly small size, smaller than an atom. At this scale, you would enter a world of subatomic particles where the rules of physics as we know them start to change. It's a realm where quantum mechanics reigns supreme. From this perspective, you would see that those stars are not just points of light, but massive balls of burning gas, gathered together in vast swirling galaxies. Each galaxy contains billions of stars, and each star could potentially host its own solar system. Our sun, the star that gives us life, is just one of billions of stars in the Milky Way galaxy. It sits in a relatively quiet neighborhood of the galaxy, providing the perfect conditions for life to thrive on our planet. And the Milky Way is just one of billions of galaxies in the observable universe. Each galaxy is a vast collection of stars, planets, and other celestial objects, all bound together by gravity. It's a truly humbling thought, isn't it? To think that our planet is just a tiny speck in an immense cosmic ocean. The more we learn about the universe, the more we realize how small we are in the grand scheme of things. To understand the universe's expansion, we must first grasp the sheer scale of it all. The distances between stars, galaxies, and galaxy clusters are so vast that they are almost beyond human comprehension. Our cosmic address is a journey through ever larger structures, from our solar system to the Milky Way, to galaxy clusters and beyond. Each step takes us further into the depths of the universe, revealing more about its structure and composition, and finally, to the vast cosmic web that stretches across the observable universe. This web is a complex network of galaxies and galaxy clusters, interconnected by vast cosmic filaments. But what lies beyond the observable universe? The edge of what we can see is not the edge of all that exists. There could be countless more galaxies and cosmic structures beyond our current reach. What secrets does the cosmos hold beyond the reach of our most powerful telescopes? As our technology advances, we continue to push the boundaries of our knowledge, peering deeper into the universe than ever before. These are the questions that have captivated astronomers and cosmologists for centuries. The quest to understand our place in the universe is a journey that continues to inspire and challenge us, driving us to explore the unknown. In the early 20th century, astronomer Edwin Hubble made a groundbreaking discovery. His observations would forever change our understanding of the cosmos and our place within it. He observed that galaxies are moving away from us, a revelation that was both astonishing and perplexing at the time. And the farther away a galaxy is, the faster it's receding. This relationship between distance and speed was a pivotal clue. This observation, now known as Hubble's law, provided the first concrete evidence that the universe is expanding. It was a monumental step in cosmology. But how do we actually see the universe expanding? It's not as if we can watch galaxies drift apart in real time. We can't observe space itself stretching, so we rely on indirect methods. These methods involve careful measurements and sophisticated technology. One such method is measuring the redshift of light from distant galaxies. Redshift is a key indicator of how fast an object is moving away from us. Imagine the sound of a siren moving away from you. As it moves, the sound waves stretch out. The sound waves stretch out, causing the pitch to decrease. This is known as the Doppler effect. Similarly, as light travels through expanding space, its wavelength stretches, causing it to shift towards the red end of the electromagnetic spectrum. This stretching of light waves is what we call redshift. This is known as redshift. It's a fundamental concept in understanding the dynamics of our universe. By measuring the redshift of light from distant galaxies, astronomers can determine how fast they are moving away from us. This data is crucial for mapping the expansion of the universe. Providing further evidence for the expansion of the universe, redshift measurements have become a cornerstone in cosmological studies, helping us to piece together the history and future of the cosmos. It's important to understand that the expansion of the universe is not like galaxies flying away from each other through space. Instead, it's the fabric of space itself that is stretching, carrying the galaxies along with it. Think of a loaf of raisin bread dough rising in the oven. As the dough expands, the raisins, representing galaxies, move farther apart from each other. But the raisins themselves are not moving through the dough. Rather, the dough itself is expanding, carrying the raisins along with it. Similarly, the expansion of the universe is not due to galaxies moving through space, but rather the stretching of space itself. This stretching is happening everywhere, all the time, on a cosmic scale. Another helpful analogy for understanding the universe's expansion is to imagine a balloon with dots drawn on its surface. Each dot represents a galaxy. Now, as you inflate the balloon, the dots move farther apart from each other. The surface of the balloon represents the three-dimensional space of our universe, and the inflating balloon represents the expansion of space. As the balloon expands, the distance between any two dots increases, just as the distance between galaxies increases in the expanding universe. It's important to note that this analogy has its limitations. For example, the balloon analogy might lead you to believe that there's an outside to the universe, which is not necessarily true. However, it provides a useful visualization for understanding how the expansion of space causes objects to move farther apart. Section 5. The Great Debate: Is our universe infinite or finite? One of the most fundamental questions in cosmology is whether the universe is infinite or finite. While the observable universe has a defined boundary, the farthest we can currently see, the universe itself might extend infinitely beyond that horizon. Imagine yourself standing on the surface of a very large sphere. You can walk in any direction, and you'll never reach an edge. This is what it would be like to live in a finite but unbounded universe. A universe that is finite in size but has no edges or boundaries. On the other hand, an infinite universe would extend forever in all directions. It's a mind-boggling concept, but it's one of the possibilities that scientists are currently considering. Section 6. The shape of the universe, a cosmic enigma. The shape of the universe is another perplexing question that astronomers are grappling with. Based on current observations, the universe appears to be remarkably flat, meaning that parallel lines will remain parallel forever. Think of a flat sheet of paper. You can draw two parallel lines on it, and they'll never intersect. This is what it means for the universe to be flat. However, other possibilities exist. The universe could be positively curved, like the surface of a sphere, or negatively curved, like the surface of a saddle. Each of these shapes would have profound implications for the fate of the universe. Section 7. The ever-expanding horizon, unveiling the secrets of the cosmos. As the universe expands, the observable universe also grows. This means that over time, we can see farther and farther into the past. It's like watching a movie in reverse, with each new frame revealing a more ancient epic of cosmic history. The most distant light we can currently detect is the cosmic microwave background radiation, a faint afterglow of the Big Bang, which occurred approximately 13.8 billion years ago. This radiation provides a snapshot of the universe in its infancy, just a few 100,000 years after the Big Bang. By studying the cosmic microwave background and other distant objects, astronomers are piecing together the history of the universe and unraveling its mysteries. Section 8. The ultimate fate of the universe, a cosmic mystery. The fate of the universe is intimately linked to its expansion. This expansion has been ongoing since the Big Bang, and it shapes the very fabric of our cosmos. If the expansion continues to accelerate, as current observations suggest, the universe will eventually end in a big freeze, with all matter and energy becoming increasingly dispersed and diluted. In this scenario, galaxies will drift apart, stars will burn out, and the universe will become a cold, dark, and desolate place. Imagine a cup of coffee cooling down. The process is gradual but inevitable. As it loses heat, the coffee molecules slow down, and the coffee eventually reaches room temperature. This is a simple analogy to understand the big freeze. Similarly, in a big freeze scenario, the universe will continue to cool down and expand, with stars eventually dying out and galaxies drifting farther and farther apart. Over billions of years, the cosmos will become a vast, empty expanse. However, other possibilities exist. The ultimate fate of the universe is still a subject of intense scientific debate and research. The expansion of the universe could eventually slow down, leading to a big crunch where everything collapses back in on itself. In this scenario, the universe would end in a fiery, dense state, possibly giving rise to a new Big Bang. Alternatively, the universe could reach a state of equilibrium, where the expansion continues at a constant rate. This would result in a steady-state universe, where galaxies remain at constant distances from each other, balancing the forces of expansion and gravity. As we continue to observe and study the cosmos, we may uncover more clues about the ultimate fate of the universe. The mystery remains, but each discovery brings us one step closer to understanding the grand design of our existence. Section 9. Beyond the horizon, the unknowable vastness. The vastness of the universe is both awe-inspiring and humbling. The observable universe alone contains billions of galaxies, each with billions of stars, and we are just beginning to scratch the surface of understanding its complexities. The concept of an expanding universe has revolutionized our understanding of the cosmos, but it has also raised more questions than answers. Is the universe infinite or finite? What is its shape? What is the ultimate fate of the universe? These are questions that will likely continue to captivate astronomers and cosmologists for generations to come. As we continue to explore the cosmos, we can be sure that the universe will continue to surprise and amaze us with its wonders. Hey there, space enthusiasts! Today, we're diving into the cosmic swell that's shaping our universe. Imagine a concentrated point at the very center of space, swelling and expanding at an incredible constant rate. This phenomenon is what we call the expanding universe. Now picture Earth's oceans with their powerful sea swells. They're influenced by our planet's magnetic core, creating those mesmerizing waves. The universe operates in a similar way, but on a mind-boggling scale. The cosmic swell isn't just a poetic term, it's the force driving galaxies apart, making space itself stretch and grow. And here's the kicker, this expansion is happening uniformly. Like ripples in a pond, except these ripples are galaxies zooming away from each other. So what's causing this expansion? Dark energy, the mysterious force that makes up about 68% of the universe, is the key player here. It's like adding more and more air into a balloon, causing it to expand endlessly. This cosmic dance started over 13.8 billion years ago with the Big Bang. Since then, the universe hasn't stopped growing. Each moment, it becomes a bit bigger, revealing more mysteries and wonders. So next time you gaze at the night sky, remember, you're looking at a universe that's continuously expanding. Who knows what incredible discoveries lie ahead as we keep exploring the cosmic swell. Stay curious, my friends.